Precalculus lesson 4.1, increasing and decreasing functions. We're going to learn some things about how to write things in interval notation, and then we'll talk about one-to-one functions, increasing, decreasing, all kinds of great stuff. So let's get started. So this graph right here, we can write this as an inequality. This is if we use the variable x, so -1 is less than x, which is less than or equal to 2. And we learned a while back, maybe Algebra 1, Algebra 2, that an open circle is for a less than sign, and a closed-in circle is for less than or equal to, because it does include that point. This we can write in interval notation, which we'll talk about in a second, but let me just show you this first. We would put parenthesis, -1, because -1 is the endpoint there, and then comma, and then 2 with a bracket. So a parenthesis means we don't include the end. And just a note, we'll see this later, infinity, if you have to use infinity, always uses a parenthesis, because we're going to use this stuff we can do that for domain and range, increasing and decreasing functions. So, but in our case up here, we did not include -1, so we used a parenthesis, and we bracket does include the endpoint. Open intervals. Open intervals are intervals that don't include either endpoint. And then closed intervals include both endpoints. So, easy enough. So we want to write the set, these group of points, in interval notation. Well, it starts at -3, and it's a closed circle, so we use a bracket. We have our comma and 4. Sometimes these interval notation things can look kind of like an ordered pair, so you have to be careful of the context of the question. All right, so now we know interval notation. On to functions. A function is one-to-one, or we're talking about one-to-one. So f, so function f is a one-to-one function if and only if f of a, so the y value when you plug in a, is equal to f of b, the y value when you plug in b, implies that a and b are equal, or a is the same as b, for all a and b in the domain of f. Practical definition. So first of all, we know that it is a function. So each x value is paired with one and only one y value. The thing is, this also goes the other direction. So each y value is paired with one and only one x value. So it's a one-to-one function. So -3 to 0, -1 goes to 2, and 4 goes to 5. I'm going to throw in another function here. Let's just look at a parabola. A parabola is not one-to-one because this y value is covered twice. If we have the graph, we can tell if something is a one-to-one function or not by using the horizontal line test. So first of all, in order for it to be a function, it has to pass the vertical line test. In order for it to be one-to-one, it needs to pass the horizontal line test, which is the same idea as the vertical line test. If a horizontal line passes through more than one point, then it is not one-to-one. So here's many horizontal lines that pass through more than one point, so a parabola is not one-to-one. Increasing function, we have a formal definition there again. Function is increasing if and only if for any 2 points, x sub 1 and x sub 2, where x sub 1 is lower or smaller than, less than x sub 2, implies that the corresponding y values of x sub 1 will be less than x sub 2. Practically, this means it goes up from left to right. Which does fit that formal definition. If you have so here's an x value and another x value. This y value that corresponds to the x value is less than this y value. And so that has to happen on any point within that interval of the function. Decreasing is similar, but it goes down from left to right. It doesn't have to be a line. It can be a curve. So maybe an exponential decay function, we could say, is decreasing. Non-decreasing. A non-decreasing. So it doesn't decrease. So it means it increases, but there's another option. It could be constant. So up, left, to right. But also can be constant. So it can have sections that are constant or horizontal, or the whole thing really could be non-decreasing and it could be horizontal, but also can have portions that are horizontal. So maybe we have non-decreasing, might be horizontal for a while, go up, horizontal again, go up again. So that would be a non-decreasing function. Non-increasing is going to be the same idea. I'm not going to write it all out again. It's going to go down from left to right, but also can have portions that are horizontal. So maybe something like that. That would be non-increasing. So just several new terms, pretty simple from this lesson here.